Oh, it's actually like
Shut up!
don't tell me.
Maybe I have my last skill. I woke up and I woke up out of my bed at 7:25.
Alright. Just a reminder that test corrections are due Wednesday. Okay? The end of the 9 weeks is Friday. So if you have any missing work, any makeup work that you need to turn in, that needs to be in by Friday. Okay? And for the test corrections, you don't have to, I mean, if you're struggling on one, you can come and ask me questions about it. You don't have to struggle on your own. Okay? You're more than welcome to ask me questions about it as well. All right, so we did reflections last week. Okay, that was our first transformation that we looked at. So today we're going to look at translations. Okay, I think translations are probably the easiest of the transformations that we're going to look at. So a translation is just vertically and or horizontally sliding a figure. Okay, we're just going to take the figure and slide it around the coordinate plane. So symbolically, okay, we started looking at these types of symbolic notations in the last section, but we're just going to say our original coordinate point, which is called xy, is going to go to x plus some number. X plus some number, call that number h, and then y plus some number, call that number k. Okay, so these numbers, the h and the k, represent how far we're shifting in the x and the y direction. So h just represents I'm shifting in the x direction, that would be the horizontal slide. And then if I'm adding something to y is the vertical direction. What's that? There you go. Hermit crabs go left and right, and kangaroos go up and down. In terms of this notation, yeah, that should help you remember it. But, I mean, if we look at this, where we're saying x plus 5, hopefully you understand that we're just adding 5 to the x coordinate, which means we're going left and right, and then adding 7 to the y coordinate, which means we're going up. So let's jump into a couple of these problems here. So it says we're given this rectangle, QRST, with these 4 vertices. So let's just start by plotting those 4 coordinates. So 6. So Q is here. R is here. S. here's my original rectangle. And it's saying take that rectangle and shift it using this rule. So I'm going to add 5 to each x coordinate and add 7 to each y coordinate. So, I mean, on a graph, what that means is I'm going to go right 5, up 7 for each coordinate point, right? And so if I start with R, 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, 7. And remember our notation for our shifted point, we put that little apostrophe up there. We call it a prime. So R prime would end up here. We just do the same thing for each of our coordinates, right? 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 1, 2, 6, 7. 6, 7. So my new rectangle is going to end up here somewhere. Right? Then we want to list the coordinates. So we could go to the graph and pick out each coordinate point, or we could just take our original coordinates and add 5 to each x, add 7 to each y. So Q will be at -1, 6. R prime will be at 2, 8. S prime will be at 6, 2. T prime will be at 3, 0. Okay, so this is pretty straightforward, right? All we're doing is moving. Yes. Right? Moving left to right, up or down. Okay, so any questions? Okay, so let's go ahead and try a couple of these here. Okay, we don't need to do all of these on the front, but at least a couple of them to make sure that we're on the same page here. So go ahead and take a few minutes and try a couple of these. Yeah, I want you to draw them out. I want you to see it too. know that we're not done with all of them, but that's okay. Okay, we don't need to finish all of these. Just to make sure that we practice a couple of them, make sure that we're on the same page here. Okay, take a look up here at the answers. I mean, here 1 through 4. So, see how you did. Okay, any questions? Alright, so let's go ahead and flip over to the back then. So the first 2 problems on the back ask us to go backwards now. Okay, they give us our pre-image and the image and ask us to write a rule. So for number 7, which one is my pre-image, the original figure? On the left, yeah, the one without the thingies. The primes, yeah. So DEF is my original figure. So what we're looking at, okay, we're saying, what do I have to do to go from here to here? Okay, so we just pick out one pair of corresponding points. So D and D prime. We're going to write our rule like XY goes to this. No, it's going to be not like a proof. We're just going to write our rule like it says on the front. You know, XY goes to X plus H, Y plus K. So all we're doing is seeing how far over we have to go and how far up we have to go to get to D prime. So I'm going to the right, 1, 2, 3, 4, 5, 6, 7. So I'm going to say X plus 7, and then I'm moving up 1, 2, 3, 4. So 5 plus 4. Okay, so that's my rule to show what happened. Okay. Go ahead and try number 8. We get X minus 4, Y plus 2. Okay. So the only potential tricky thing on something like this, right, is making sure we understand where we're starting and where we're ending. Okay, so looking at which direction we're going. So that's the tricky part, is looking at where we're starting and where we're ending. So here's P and here's P prime. So I'm starting here, going left 4 up 2 to get from here to here. So you got to make sure that you're going in the correct direction, right? Looking at where you're starting and where you're ending. Okay. Questions on those? All right. So then the last part of the notes here is combining reflections and translations. Okay, we're going to do 2 operations for each of these. So for number 9 here, okay, it says take this triangle with vertices x, y, and z, first reflect it in the x-axis, and then take that new figure and translate it right 9 up 2. Okay, so let's go through this one together. We're going to do all 3. So I'm going to start at negative 3, 7, negative 2, 1, and negative 5, 2. So here's my original triangle. So I'm first going to reflect this in the x-axis. So it's going to flip down here. Right? So to do that, we're just counting the distance each point is from the x-axis, and then going that same distance on the other side. Okay? So we'll label that y prime, then z prime will be here, x prime, 7 will be right here. Okay. So now I'm going to take this figure and shift it right 9 up 2. So it's going to count 1, 2, 3, 4, 5, 6, 7, 8, 9 up 2. Now I'm going to label these double primes, since this is the second operation that I'm doing on each of these points. So 2 and so this is where my figure will end up. Okay? After a reflection across the x-axis, and then a translation of right 9 up 2. So these actually should be double primes over here. Okay, so we want the final answer: x double prime, y double prime, z double prime. So those coordinates are, let's see, 6, 5, negative 5. Y double prime is at 7, 1. And z double prime is at 4, 0. Okay, so we're just combining the two ideas that we've talked about so far for transformations, okay, reflections and translations. Questions? Okay, let's take a couple of minutes and try some of these. Yes.
Oh my gosh, do the translation.
Alright, take a look up here. Okay, at number 10. Okay, where we first reflected across the line y equals x, and then translated left 3 down 7. Okay, as I was walking around, there were a few people who forgot how to reflect across the line y equals x. Okay, if my original figure is down here, then to reflect across the line y equals x, we count the distance to that line. So if I'm looking at q, that'd be 1, 2, 3. Then I go up 1, 2, 3 to get to q prime. Right? We can't just go that distance across, because if we think about folding across this line, if I put my figure 1, 2, 3 over here, and I fold across this line, that's not going to match up. And so to reflect across y equals x, we count 1, 2, 3 over, then 1, 2, 3 up. It would, yeah. So if we go up 1, 2, 3, then left 1, 2, 3, we'll end up in the same spot. Yep. Okay. So questions on number 10? Okay, I know you probably didn't get all of these done, but you're supposed to try. Yeah, I need to. So here's 11 and 12. So any questions at all on translations?